we can most likely continue tomorrow, but I will let you know. Okay. So again, like your exam is going to be, start off study unit 1, then study unit 2, study unit 3. So the first two questions normally will be around types of variables. So in this instance, and let's see if we can get it still a bit bigger. Oh, okay. Which one of the following statements is firstly correct with regard to variables and descriptive stats? Okay, so the first one, quantitative variables are also referred to categorical. Categorical, no. If it was qualitative, then it would have been correct, but quantitative is always your numeric variables, so definitely not categorical, but we're looking for the correct one. Descriptive statistics is the process of using data from a sample to make estimates and test hypotheses about characteristics of a population, like drawing conclusions on a population based on a sample. Sample to make estimates and test hypotheses about characteristics, but drawing conclusions, a population based on, okay, what would you guys have said around this one? Descriptive stats is the process of using data from a sample to make estimates and test hypotheses about characteristics of populations. Okay, so that is the one where, so descriptive stats is the process of using data from a sample to make estimates and test hypotheses about characteristics of that sample. And when you're drawing conclusions, population based on sample results. Okay, so you are drawing conclusions from a sample. So that part is correct, but you basically checking the characteristics of the sample. Counting attributes. So then we go into quantitative. Oh yes, sorry. I was now so descriptive stats is looking at mean, mode, those things. The other one is this. I was so fascinated or looking now at sample versus population. I actually missed. The other one is inference. You're making inferences about. So this what we looked at here is actually the inference. Sorry, thank you for that one. I was so fixated on looking for where they are talking about sample and populations. Okay. Counting attributes, counting quantitative. elements results in quantitative. Okay, so why can that be? Counting attributes of an element results in a quantitative, that is correct, quantitative discrete variable. So the only thing that I can think of here is that we want to classify it further. Let's just see the others. Quantitative variables have either nominal or ordinal. That is incorrect. I'm looking for the correct one. Counting also shows how you need to think in the exam. Um, Counting attributes of an element results in a quantitative discrete variable is correct. I'm looking for the correct one. Sure. Um, Quantitative variables have either a nominal or ordinal scale. Incorrect. It's qualitative. Quantitative variables use labels or names. Incorrect. Again, qualitative. Important in this one again, and I even highlighted it for me to look for the correct one. But when it came to the correct one, it was also like, okay, why? What's wrong with this one? Okay, cool. So that is hopefully the second one will go simpler. Let's see. So consider the following information about type of variables related to autonomous vehicles. Which one of the following statements is incorrect? Okay, so the type or name of speciality of each business in the self-driving car market, engineering, software development, is qualitative, correct, nominal, correct, because there's no order in that. So that is a correct one. We're looking incorrect. The cost of production of each car in rands, it's a quantitative continuous variable. Okay, so it that one is interesting. So it's quantitative. Continuous is an interesting one, but it is not because we can count it, so we don't know. So it can go on. See, that is what I'm also now thinking. In rands means to me 1 rand, 2 rand, 3 rand, 4 rand, which is discrete. So that's why this one is, for me, I would have said discrete. The same year, if driving speed in kilometers per hours of a self-driving car is quantitative, yes. Discrete, yes, but now that is set as the incorrect one. So these two, I would have both said, because they say in rands, because they say in kilometers, it's 1, 2, 3, 4, 5 kilometers is 2, 3, 4, 5 or whatever kilometers. So both of these would have been for me quantitative discrete. So I will just find out about that one. Um, Type of name of sensor used: camera, LiDAR, radar. Qualitative, yes. Nominal, yes, because there's no order. Size of business, again, qualitative. There is order. So those two are definitely correct. Okay, so I would have been between B and C. I would have been, I probably would have said that that B is the incorrect one. Okay, so I will just find out about why that was now suddenly classified as that. Frequency tables. Okay, so now we go into study unit 2. It did a bit that we can see a bit clearer. Okay, so still with the motors. So there was an estimated 3,100 autonomous vehicles on the road. The include complete table below shows the manufacturing frequency. Okay, so there we need to have work out that, but let's first go to the numbers and let's see at what stage do we need to work out general motors. Okay, so relative frequency. So relative frequency we will need to also work out. So let's first see if there's anywhere frequencies that we need to do. Then that's for relative. Okay. So we, in any case, need to work out the relative frequency of that. So let's quickly do that and see if that is the simplest one to answer. Okay, so 3,100 minus 465 minus 248 minus 713 minus 155 minus 950 gives me 589. Okay, so we know 589. We're looking for incorrect one. Okay, so 589 is correct. Okay, relative frequency, just taking the frequency divided by 3,100. So let's look, we need to get the fourth one. So that is 248 divided by 3,100, 0,08. Okay, so that is the incorrect one. Let's just look at the others. Relative frequency of Tesla, 465 divided by 3,100, 0,15. Okay, so that is correct. Relative frequency, percentage frequency of Google. So 155 divided by 3,100 times 100 to get percentage. That is 5%. And Daimler 713 divided by 3,100. That gives us 0.23. So if we multiply that by 100, we get 23%, which is also correct. So this one basically looking at frequency, relative frequency, and percentage of frequency. For this one, remember, this is qualitative data or categorical data. So then you can't work out cumulative frequency because it does not make sense. Okay, so you will not ask a cumulative frequency of Tesla, General, and Ford because it does not make sense. Yeah, so for me, just looking at the previous one, normally things like distance, time, those things are continuous. Um, and when if they, but when they say things, so, and when rands that you can count, that is normally discrete, or if I say count of, then it's normally discrete. So yeah, I just want to make sure about that one, but distance and time and is normally a continuous. Okay, so can see now we jump suddenly into, just want to see if we missed, yes. Okay, the data below shows the production cost in dollars of 10 autonomous vehicles. Calculate the interquartile range for the cost of production and choose the correct answer from the list below. Okay, so let's just see if I've ranked it, because that will make it simpler for us. It is ranked. So basically, what we need to get for interquartile range is to get Q3 minus Q1. Okay, so let's just look at these answers. So my range is going to be 895 minus 300. Okay, so my range is going to be, what is that, 595. So my interquartile range can't be bigger than that. So if I look at answers, definitely not that, definitely not that. That 571 is really pushing it. So I would probably have said also not that one, because that is very close to the range and you're looking at interquartile range. So you need to work out Q3. So 3n plus 1 divided by 2. I said, I think it's 10. So 3 times 11 is, sorry, and this is divided by 4. N is 11. N is 10. 10 plus 1 is 11. 11 times 3 is 33. Divided by 4. So that is 8 point something, but let's just quickly 8.25. So we're looking where the position is of 8. So 1, 2, 3, 4, 5, 6, 7, 8. So the value is going to be 8 for 8. Okay, so that is going to be the 1. Q1, 1 n plus 1 divided by 4. So it's 10 plus 1. 11 times 1 is 11. 11 divided by 4 is 2.75. So 2.75 is the position of 3. 1 to 3 is 571. Okay, so you guys can see what they did here. That is Q3. That is Q1. If you subtract the two, 848 minus 571 gives you an answer of 277, which is option D. Okay, so basically for this one, it was already ranked. So all that we needed to do was to say, work out your interquartile range, Q3 minus Q1, and that is how we got it. Yes. Question.
Good morning, sir. Um,
Mornings.
I want to know, like, so, if it's 0.25, we go down the number. If it's a 7.5, we go up. If it's 0.5, do we then take the
Middle.
positions of the two?
Yes. So
Okay,
if it's 0.5, you take what's in the middle. Yeah. So that's why your Q2 would have been, so let's just work out Q2, that's the median. So always the one in the middle. So it would have been 11 times 2, so 22 divided by 4. Oh, don't know why it moves like that now. So that is 5.5. So we would have used 5.5. So 1, 2, 3, 4, 5. So whatever is here in the middle would have been. So what we normally then would do is to say 735 plus 770, and that answer divided by 2, because that is what you will get in the middle. Cool.
thank you.
Quickly want to save this document so that it hopefully does not jump around like that. Okay. Now we go into a bit mean median mode, and let's first just see the whole question. I can probably make it one or two. No. Okay. Okay. Now we're looking at, consider the production of those 10 cars. Which one of the following statements about measures central tendency is incorrect? So basically looking at mean, median, and mode. Okay, so let's just see again, data is ranked. So I will, for me, the most easier one is to get the mode. Mode is the one that happens the most. So is there anything happening? There's one that's happening twice. Cool. So that is our mode. Let's look at median. Median is the one in the middle. 4, 5, 6, 7, 8, 9, 10. So between 5 and 6, 1, 2, 3, 4, 5. Okay, median in the middle. Incorrect, 1093. Okay, so then let's just look at the other two. So the one is asking us about the distribution. Is it symmetric? So it can only be symmetric when mean, median, and the mode is exactly the same. At the moment, median and mode is the same, so most likely mean will also be, but let's just test it. So 689 plus 757 plus 913 plus 932 plus 1093 plus 1093 plus 1226 plus 1338 plus 1415 and then plus 1474. We divide that by 10. Okay, the mean is also 1093. And because mean, median, and mode is exactly the same, the distribution will be symmetric. Okay, so then basically what is happening, all of those numbers are exactly the same. So the mean, the distribution will be a normal distribution. In the end, it's symmetric around the mean. Okay. Okay, so now we're going into a bit more difficult because now same, okay, just one of the other car brands, but now they want us to calculate the standard deviation of production cost and choose the answer of the list. Okay, so now, unfortunately, here again, it's gonna take lots of time to calculate this by hand. If your calculator can do it, great. Else you can use Excel. So let's just put these numbers in and then I will make it bigger again. Okay. Okay, so we have our 10 numbers. Then built into Excel is your variance and standard deviation. Okay, so let's just first, they say there's the 10 cars. So we know it's a sample and we need to work out the standard deviation. They don't tell us its population or sample, but we need to work out when we assume we're working out the standard deviation of a sample. Okay, but let's first work out variance. Okay, variance, big number. Um, and then standard deviation of a sample. Okay, so let's hope there is 916. Okay, 916. Okay, luckily there's not anything else close by that now could have maybe think about the population. But yeah, once again, we're working with a sample. They did not tell us that we need to look at the population. So then we take what we have, and that is when we work with a standard deviation of the sample. And let's look at the next one. So that was still study unit 3. Okay, then we go, and it now seems like we're going into probabilities. So going into study unit 4, which one of the following statements is incorrect with regard to experiments and counting rules? Okay, so this is normally a question that they love to ask, um, because it does test a few things. So we will most likely be in a question around permutations, where there will be in question about combinations, and then one or two other questions as well. Um, so experiment with 4 steps and 5 outcomes possible for each step as 6 to 5 experimental outcomes. 4 steps, 5 outcomes. Okay, so we could have drawn it. I'm now not just going to start with it. So um, 5 outcomes. So each of those 5 outcomes have another 5 outcomes. Each of those have another 5 outcomes. And then each of those have another 5 outcomes. Okay, so you can now see there's going to be 5, 5. So it's going to be, so what we have is 5 times 5 times 5 times 5. And so that's the easiest way of working that one out. So 5 times 5 times 5 times 5 gives us 6 to 5. And so correct, but we're looking for incorrect. Okay, the number of permutations of 4 items that can be selected from a group of 6 items. Okay, so let's just get, where is that on my, ooh, my calculator didn't even have it. Shucks. Okay, it's normally I think it's, sure. Now, I can't even remember how it is written, so let me quickly just, that was standard deviation. Let's do it on this one, permutations and combinations. And let's just make it bigger. And when you can, I'm going to make it so that you can change it. So 4 items, 6. Okay. So permutation is at least function for that. Okay, permutation number is the total number of objects. Number chosen 4. The permutation is 360. Okay, so permutation 360. On the calculators, there's normally an NPR. So it's normally written NPR, and then for combinations NCR. So that's normally on the calculator, but I cannot seem to find mine on the calculator at the moment. So, but that's normally what you will look for on a calculator. Okay, so that one is also correct. And then the number of combinations of 5 items that can be selected from a group of 9. Okay, so let's just block that. And then 9, 5, combination. So again, there is a combination formula number there. The chosen one is 5. And then for combination, we get 1, 2, 6. Okay, so again, permutation, combination, if you want to use Excel, but on the calculator, that is also how it is written. Okay, cool. In an experiment with 16 equally likely outcomes, each experimental outcome has a probability of 1, or 0.16. Okay, so let's see. So for that, it needs to be, if it's equal outcomes, what is 1 divided by 16? So 1 divided by 16, right? 1 divided by 16 gives me 0.0625. That's why that one is incorrect. So in an experiment with 16 equally likely outcomes, that means each outcome has a likelihood of 1 divided by 16, and that is then equal to 0.0625. It's easy to make this mistake because you think 16, you see 0.16, you just mark it as correct. Okay, so easy to make this mistake. Then a classical method of assigning probabilities is appropriate when all experimental outcomes are equally likely. Okay, which is correct. And an example like that is tossing a coin, equal likely to get a heads or tails, throwing a dice equally likely to get a 1, a 2, a 3, 4, or a 6. Okay, so that is just examples of something that is equally likely to happen. Okay, so that is normally how they introduce your probability, and then we go into one or two probability questions. Okay, so let's see what we're asking this one. Got a contingency table. Then we say calculate the probability that an autonomous vehicle is self-driving. Oh, okay. And let's just self-driving bus, because there's two self-driving, so just not be caught out with that. Self-driving bus, or let's just write probability self-driving bus, or that its level of autonomy is conditional automation. And so there's conditional automation. And so that will then normally be probability of self-driving bus plus probability of conditional, let's just make that A, that conditional automation minus the probability of those twos and. Okay, just things to pick up here. So where you see a 0, that is a true reflection. It's not that there's a gap. So self-driving bus, partial automation, mutually exclusive because there's a 0. Civil vehicle, partial automation, mutually exclusive because there's a 0. Civil vehicle, conditional automation, 0. So those two are also mutually exclusive. So just to reiterate, when there's a 0 in a table like that, it means those two variables are mutually exclusive. Okay, so let's look at self-driving bus 279 divided by 3100. Let's just, in any case, just work it out, then makes it simpler for it later. So 0.09. Okay, interesting, nothing there. Conditional automation, 536 divided by, so let's just do that, 536 divided by 3100. Okay, plus 0.17. Okay, so, and then subtract the and, so self-driving and conditional 89 divided by 3100. That is 0, I'm just going to keep those 87, but we could have probably said 0.03, but that was 89 divided by, okay, so 0.09 plus 0.17 minus 0.0283 gives us 0.23. Okay, which is option B. Okay, so basically this is your normal, or you don't need to worry about that they're trying to catch you out here or anything. Probability of self-driving bus plus the probability of a conditional minus the and of the two. Okay, oops, let's go down differently. Okay, so again, we're working with the same table. Once again, consider this table. Calculate the probability that the level of autonomy for an autonomous vehicle is high or an autonomous vehicle is high automation, high automation, given that the vehicle is used as a ride hail. Okay, so that's nearly like a Uber. Okay, probability, high automation, probability. Okay, so remember the given one, we look at probability, high automation, and the right tail divided by the probability of the last. Just give me a second. Okay, cool. So let's see probability of high automation, right tail, 393 divided by probability of right tail, 868. So that looks like something like 0.3, but let's quickly check. 393 divided by 868, 0.45. Okay, cool. Okay, I would have probably, if I needed to guess wrong. Um, but you've got the and, so it's 393 divided. I first circled that one, but remember it is the right whole because that is one that's last. So it's divided by 868, which gives you 0.45. If you said 393 divided by 1482, it was actually then 0.27, so there wouldn't have been answer. Okay, not too bad then. Okay, so that was now two probability questions or actually three probability questions. The one was looking at your permutations, all those kind of things. Then one was looking at the or, and the other one was looking at the given probability statement. Okay, so what you guys will also have seen with this one, how it was previously done is there was two exam papers. So the one was about on study unit 1 to 5. Then you needed to log off and log into a new exam to start off with question 1 again. So they have changed that you only write one exam because it did give lots of problems. So study unit 5, discrete probabilities. The following discrete probability distribution shows the number of self-driving cars and the probability of spotting them in Pittsburgh during peak traffic hours. Calculate the expected number of self-driving cars that can be spotted during peak traffic and choose the correct answer. Expected number is basically the sum of these that we multiply. So again, I'm doing it quickly on my cell phone calculator. Probably going to take longer for me to type it in Excel if it was standard deviation or variance, something different. But here I know that is 0. 1 times that is 0.22. 2 times that is 0.42. 3 times that is 0.45. 4 times that, I think it's 0.08. So then easier to just add that. So 0.22 plus 0.42 plus 0.45 plus 0.08 gives us 1,17. Okay, 1,17. Okay, so just adding all of those together gives you the 1,17. So if next question is to work out variance or standard deviation, then I will go to Excel. But this was quick enough to get to the answers that I was looking for. Okay, so let's look at the next one. So discrete, then most likely binomial, unless they give us another discrete. Okay, so binomial, but now it's about, they don't ask us to work it out. They want us to consider the binomial experiment of 8 trials, and the probability of success is 0,09. Use the binomial formula to determine the probability of exactly 1. And they're not going to ask you with a question like this to work out for binomial for x bigger than 1, or that you need to have 3 or 4 of it for a formula. For the formula will always be just referencing 1. Even Poisson, if they want nearly to see if you can use the formula again, it will be referencing 1. It will not go into that. You need to now work out what the answer is for even x smaller or equal to 1 that you need to work up to, that will not happen because that is just too much time. And so what they're testing here is that you can use the formula um, and substitute values in that formula. So I will reshare that formula page again. That is just top of mind in the chat because it is now some time back. So let's quickly see because they do give us the formula. So not please don't go and study the formula. It is also in your guide. Please don't go to that effort to memorize this. We will, as we go now through it, substitute, and you will see it's actually not too bad. But please don't try and go and remember. Okay, so it is x. Ooh, just need to write it a bit nicer. N minus x. Okay, so let's see. N is 8. X is 1. So 8 minus 1 is 7. 5 I've given us as 0,08, 09. X is 1. Then 1 minus that. N minus x. So again, 8 minus 1 is 7. So what I normally do is I look at this component first. So 1 minus 0.09 to the power of 7. Because those two you can multiply out, but 0,91 to the power of 7. Okay, not that one. Might be. Now that's only that component, so no. And again, wrong. So we're sitting with option of 2 that we need to work out. So not too bad. I want to rewrite this a bit so that so that normally is 8 times 7 times 6 times 5. So 8 times 7 factorial. And then at the bottom, we've got 7 factorial. So those two will cancel out. So we're actually sitting with 8 times 0,09. So 0.09 times 8 is equal to 0,72. And that we just carry over. The 0,72. There we have it, option 2. Okay, so yeah, basically use the formula, substitute, and get to the right answer. This would not have now help you to go to the table because it's not written in a probability. This you would have still worked out to get to a probability, but who knows what that would have been and how you work it backwards. So not even an option to really use that. Okay, so now we go into the last two questions to end off up until study unit 5. So recent reports of self-driving car crashes has resulted in safety concerns and consequently a delay in their rollout. Suppose that the number of crashes is Poisson distributed, so they tell us that the mean of 0.1 crashes per year. What is the probability of having only one driving car crash? Okay, so probability of X is equal to 1. Okay, so this, we need to again get to that table. So where is my... Okay, so we're going to Poisson probability. Zero 0.1, only one is 0, 0,0905. 0,0905. 0.0905. Okay, look at just if we looked at, if you looked at the 0, I don't think there was on. Yeah, so there's if X was equal to 0, if X was equal to small or equal to 1, there would have been an answer for you as well. Okay, so just be careful that you don't look at the number, you first see the 0,9048 and you think that's the first number because they tell us 1 and you think it's first number. So just be very careful with this one. Okay, and then another Poisson. So suppose Ford Motor conducted their own research and found that the mean is 0,08. What is the variance of that? Okay, so lambda is 0,08. That means the mean is 0,08. And that also means that the variance is 0,08. So remember, for Poisson, those three things are always the same. And so correct answer would have been 0,08. Just be careful sometimes with a question like this is that they don't ask you here what's the standard deviation, but just be careful that they don't sometimes throw in standard deviation and one quickly forget with the rule is mean lambda variance is the same, but they throw in standard deviation and you might then still pick the 0.08. So just be very careful for that one doesn't make that mistake. Okay, so that is the first 5 study units of the exam. We're gonna have a session tomorrow, but it will be tomorrow afternoon. It will not be a morning session. So just gonna look at my schedule, but I think around 3 or 4 o'clock tomorrow afternoon, um, we'll do the rest. That we then look from study unit 6 onwards, and then in the week we will just have a catch up on Wednesday. That anything else that you guys are still not clear on, um, you can ask on the WhatsApp group, or but we will check in on Wednesday so that if there's anything still unclear, you can ask the questions. That we just sort that out. So tomorrow afternoon we'll have another session to round off, and then in the week we can just focus on anything that you guys still need clarity on. Cool, great everyone. Have a wonderful Saturday further. We will definitely chat tomorrow again so that we can finish this off. That at least we've worked through a lot of other problems when we've worked through 2 exam papers as well. And then if anything else is still that you need clarity on, we do that in the week. Cool. Thanks everyone. Have a great Saturday and see you tomorrow afternoon again. Cheers.
Bye.